Hello, everybody. We are going to be going through the final section in Unit 4, Quadratic and Polynomial Inequalities. It's super exciting. It's just like all the other inequalities we've done. We're going to have to do a little bit of factoring in the beginning, though. So we're going to go ahead and get started. The solution to a polynomial inequality, quadratic or any other type, is an interval of real numbers. So what that means is there's going to be sections of the number line that we're going to shade in just like we have in the past. So what you want to do first is if we're solving x squared plus 2x minus 8 is greater than 0, so we're solving this right here, the first thing we want to do is change that sign to an equal sign and go ahead and solve the equation just like we have in the past. So think back to chapter 1. When you're solving these equations, you can do the quadratic formula, you can do completing the square, or you can factor. So we're going to go ahead and factor. So we need factors of 8. Well, that's 1 and 8, 2 and 4, and we need a set that can get us to 2. So we're going to have x's in the front. 2 and 4 will multiply to give us 8. A positive 4 and a negative 2 will give us that positive 2 in the middle. And we want to t-bar it, so we have x minus 2 equals 0, and x plus 4 equals 0. If you finish solving those, you'll end up with x equals 2 and x equals negative 4. What you're going to do from here is exactly what we did with all of the other inequalities. We want to make a number line, divide it into 3 sections using those solutions we just got, the x equals 2 and the x equals negative 4, and then we're going to decide where to shade from there. So we are looking for where x squared plus 2x minus 8 is positive or greater than 0. And what I would like you to do next is go ahead and cross off the rest of that paragraph because we are not going to be doing that. We actually have a different technique that's a bit easier. So instead of figuring out positives and negatives and all that crazy stuff, we are not using any of that. So all you need to have is this part right here. So we know that our solutions for this were x equals 2 and x equals negative 4. So you're going to take a number line. So you can draw your number line. That's not a very good number line. Let's make it a little bigger. So you're going to draw your number line right here. And you know that it needs to go from negative 4 to positive 2. So we're going to go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Actually, I'm going to start at negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, like that. We're going to put some open circles. And look at that. I already screwed up because we have to go all the way to negative 4, not negative 3. So we're going to start at negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. If you copied that down, I apologize. But life is learning from our mistakes, right? So we're going to have an open circle here at 4, and we're going to have an open circle here at 2. And now you're going to split this up into your sections. So here's one section, here's the other section. And you need to decide, when you plug in something back here, is that going to give you a correct solution? So going back to the original, you have, let's just pick negative 5. So it will be negative 5 squared plus 2 times negative 5 minus 8. And we want to know, is that greater than 0? Well, you can actually plug that whole thing right there into your calculator, and it will give you back an answer of 7. So is 7 greater than 0? Yes, it is. So we want to shade that area, making sure you have your arrow. You need to pick a number in the middle. So we're going to pick, let's say, 0. So we'll have 0 squared plus 2 times 0 minus 8. And we want to know, is that greater than 0? Well, if you plug this whole thing here into your calculator, it's going to give you negative 8 is greater than 0. That is not true, so we do not shade there. And last but not least up here, let's pick 3. We'll have 3 squared plus 2 times 3 minus 8, and we want to know, is that greater than 0? Well, when you plug that all into your calculator, it gives you again a 7, which is greater than 0, so we do want to shade this side right here, making sure we have our arrow on the end. So your final solution there should look something like that. Moving on to the next example. If we want to solve this inequality, we want to do the same thing. We want to start off by changing it to an equation. So we're going to have x squared minus 4x minus 5 equals 0. Again, we can factor this. So we're going to have x and x. We need factors of 5. Only two factors of 5 are 1 and 5. We want a negative 5 and a positive 1. When you t-bar that, you'll have x plus 1 equals 0, x minus 5 equals 0, so you get x equals negative 1 and x equals positive 5. Let's use this color. That sounds good. So we're going to draw our number line. And we know that our number line has to go from negative 1 to positive 5. So I'm going to start one below that. So we have our number line here. We're going to put closed circles this time. On negative 1. And a closed circle on positive 5. And I should have gone one more to go to 6. And we're going to split that up. So we have this section, and this section, and this section. You can plug in one number from each of those sections. So I would probably pick something like, I don't know, negative 3. So negative 3 squared minus 4 times negative 3 minus 5. And we need to know, is that less than or equal to 0? Again, you can plug this whole thing right here into your calculator as long as you use the parentheses like I did. And when you do plug it in, you'll get 16 is less than or equal to 0. That is not true. Picking a number in the middle like 0. I'm going to change this here so we know. We have 0 squared minus 4 times 0 minus 5 is less than or equal to 0. Well, in this case, if you plug this whole thing in to a calculator, it will give you negative 5 is less than or equal to 0, which is true. And then you pick a number above like 6, so 6 squared minus 4 times 6 minus 5 is less than or equal to 0, and that again will give you a large number like 7, which is not less than or equal to 0, so we don't shade there. So our solution for this section, you would shade right in between here, in between negative 1 and 5, with both end values being included. Alrighty, just a couple more examples here. This one's pretty straightforward. We have x minus 1, x minus 2, x minus 3, all in parentheses, so they're all being multiplied. The beautiful part about this is it's already factored for you. So all you have to do is t-bar it. So you have x minus 1 equals 0, x minus 2 equals 0, and x minus 3 equals 0. So we will get solutions of 1, 2, and 3. So we're going to go ahead and make our number line. And I'm going to spread this one out a lot. So I'm going to go 0, 1, 2, 3, and 4. And I spread those out a lot because we need to pick numbers in between here. So we are going to have open circles on 1, 2, and 3. And we need to pick numbers in between because we now have 4 sections for our number line. If we plug in 0, that's 0 minus 1 times 0 minus 2 times 0 minus 3. And we want to know, is that greater than 0? If you plug that whole thing in, you end up with something like -6 is greater than 0, which is not true. So we know we're not shading there. Now you need to pick a number in here. I would pick something like 1.5. I'm not going to write out the whole thing. If you were doing this on an exam, you would need to write it out though. If you plug 1.5 in, you end up with 1.875 is less than 0. Oops, I apologize. Looking at the wrong problem there. You end up with 0.375 is greater than 0, which is true. So we are going to shade it in between there. I would pick 2.5 for in between here. I like picking things that are nice and in the middle. When you plug 2.5 into the equation, so 2.5 minus 1 times 2.5 minus 2 times 2.5 minus 3, you end up with negative 0.375 is greater than 0, which is not true. So we are not shading there. And if you plug in 4 minus 1, 4 minus 2, 4 minus 3, you'll end up with 6 is greater than 0, which is true. So we would end up shading that end section there. This is just like all the other inequalities. Split it up, pick which sections it goes into. Last example. We are going to need to factor this a little bit. So the first thing you want to do is turn it into an equation. So x to the third minus 2x squared minus 3x is less than 0. If you notice, there's an x in all three terms. So you can pull one out in front. So x, and what's left over will be x squared minus 2x minus 3. That should have been an equal sign. Equals 0. We can do a little bit of factoring so that x on the outside comes down. Factors of 3 that can get us to 2 have to be 3 and 1. We want a -3 and a +1. And then we are going to t-bar. So you will end up with x equals 0 for the first one, x minus 3 equals 0, and x plus 1 equals 0. So those other two solved out would give you x equals 3 and x equals -1. Drawing our number line. We need to go from -1 all the way to +3. So I'm going to start one behind that at -2, -1, 0, 1, 2, 3, and go one above it all the way to 4. We need to have open circles here on 0, on -1, and on +3. So we are split now into these sections of the number line. Once again, I'm not going to go through plugging everything in. You need to be able to do that on your own. So what will end up happening here is if you plug in -2, you will end up with -6 is less than 0, which is true, so we will end up shading there. -0.5 will give us that 1.875 is less than 0, which is not true. If you plug in a 1, you get -4 is less than 0, which is true. And if you plug in a +4, you end up with 20 is less than 0, which is not true, so we're not shading there. True. So this is something that we've done in the past, a lot of it. The only difference is now we're taking parts from Chapter 1 and parts from Chapter 2 with the inequalities, and putting them all together. We will practice this in class tomorrow. Have a wonderful day.